Hello everyone. In this video, we are going to talk about collections as well as grouping. So if you have several objects in the environment and they kind of serve the same purpose, you can group them together or you can add them to a collection. Like what? Like look at here, let's say this is a room with walls and door and sofa, and this robot is moving inside this room, and you want to check whether there is a collision between the robot and the rest of the stuff. So all of this stuff that you can see in this room, wall, furniture, door, everything, you can merge them into one single, what we call collection, and we check whether the robot has a collision with any of these instead of we check each individual one and run it in a for loop and go from object 1 to object 2 all the way to object n. We can check whether this robot has a collision with the whole collection of the objects. And that will facilitate the calculations, and that is what we call a collection. So here I'm going to show you that collection here. And that is one of the things, and it's different from a tree. If you look here, this robot, if you look at this robot, it has a bunch of elements in it. It has a bunch of shapes and joints and everything. But if you can see here, there is an order. There is a hierarchy here, and some members are below some other ones, right? So you see this basically shape and this primitive shape are under this joint. So there is hierarchy. So if I move the joint, everything that is a child of it will move with it. A collection has no hierarchy. So if I put all of these walls and sofa and door in a collection, none of them is a child of another one. No hierarchy, okay? So if I want to explain that a little bit for you, there are three major things that we have in Coppelia. One of them, as I said, is a tree for hierarchy. The other one is a collection, and we can also group or merge objects together. So what's the main difference? Structurally, because tree has hierarchy, so the motion of the parent will affect the motion of the child. So there is that relation. In collection, there is no such a thing. When we group objects together, as we'll see, they become literally one single shape. So when you move one of them, all other ones will move the exact same thing. They become literally a single object. In terms of a logical group, in tree, each one of them is a separate object. I can get the handle of them, and I can basically do all sorts of operations individually. In collection, they become logically the same group, not structurally, just logically. And group objects, again, logically, they can be separated. Instead of physical merging, in tree, the objects are not physically merged. In collection, they are not physically merged. But in grouped, they are physically merged. And so you can see that the advantage for this grouped object is you have mesh simplification and better performance, because instead of dealing with 10 walls, you only have one collection of walls. For collections, basically, because they are logically connected and become one object, again, that makes your checking for collision, for proximity sensor and so on, a lot faster than going through individual ones by a loop. But in tree, of course, it's a parent-child motion, and so it takes a little bit more time when on performance when you have to deal with a tree. So this is the difference between a tree, a collection, and a group of objects grouped together or merged together. Now, before I go and show you the collection, because that's the main focus of this video, I want to show you the collection of objects, how to create a collection, because it has to be done with a script. It has to be done through a code. And I want to show you how to check the collision of a robot with the collection. So I'm going to show you this. Before that, I want to talk a little bit about the grouping and merging, because tree, I'm going to show you in one of my future videos when I show you how to create joints and add members to the joints and so on. So this is a future video. But I want to talk a little bit before that about grouping and merging, because you can do both of these operations on a bunch of objects, and all you need to do is to highlight them and merge them or group them. So let me show you that in Coppelia. So if you look at here, I have these two walls, right? Wall 0 and wall 1. And I can simply highlight both of these with Control. And then if you go under Edit, you see that I can do what? Shape grouping or merging. You see, I can group them or merge them, right? So what is the difference? If I group these two, and then if I pick these two guys, and then I go under Edit and say, for these two, go ahead and merge them together, right? So what is the difference between these two that are grouped and these two that are merged? Okay, yes. First, let's take a look at that. So both of them, of course, will combine all of the objects into a single object. So in this part, they are very similar. What about the meshes? So here in grouping, you will have sub-meshes. So if wall 1 has one type of mesh, wall 2 has another mesh, if sofa has a different mesh, door has a different mesh, when you group them, each one will keep its own mesh. But in merging, they become a single mesh. So merging is a more simplified version of grouping. And when you mesh these objects by grouping them together, but they keep their own mesh, typically you can reverse it because their meshes did not combine into a single one. They still have their own structure and mesh, so you should be able to reverse it, but in merging you cannot reverse it anymore. You cannot ungroup them. And about the vertices, of course, because the meshes become one thing, so here the vertices of the mesh will not join together. Here they will. Okay? And so this is a composite mesh. This is a single continuous mesh. And what are they best for? Grouping is best for simplifying the scene, while meshing is better for geometry optimization and solid modeling. So this one will help you get faster computations done. Let's say when you want to check collision, or when you want to check use a force sensor, as I'll show you, this is gonna make the code faster, especially if you don't have any difference between wall 1 and wall 2. It's better to merge them. Grouping is basically good just for simplification. And you might say, what kind of simplification? Well, let me show you. So here, let's say I made these two walls and I want to keep them in the same relative position. Just I want to move them from this point to this point or somewhere else. Instead of clicking on each one of them and then basically grab this object movement and move each one of them to a new point, and then make sure the same distance or the same configuration between them, the same relative position and angle between them stays the same, I group them together. Now I can move both of them with one single command. You see? Now they act like a single object. So this is, in CAD software, we call this fix. We fix these two objects together. You see here, they move together. We can rotate them together, right? So this is really convenient when you want to remodel your walls or move them or something. This can be very useful, right? But you can see the same effect here for the merging. You can clearly see that the merging has the same effect because both of them are the same object. The only difference is now these two objects basically became two different meshes. Now in this case they are copy paste of each other, so the meshes of the walls are not different. But if in this case, if I group this wall with this sofa, then the meshes of them are different. So merging is not really a good idea if you want to keep their structural elasticity and so on to be different. Okay, so this is about grouping and meshing. So just looking at the group and looking at the group and merge, visually they look very similar. But the thing is, let's see if I go back on this group. So this is the group here, and look at the difference it makes. Remember, I had 4 of these plus signs, right? For each one of these items, I had a plus sign. I could expand them, but now look, these 2 share the same plus sign, right? You see that? Basically, these 2 have the same icon. So now if I want to, let's say, change the color or the geometry or anything or appearance, when I change any of these, then I can change both of them at the same time. Okay, yes? So, and a similar thing for this one. Now, if I just grab this guy and go to edit, let's see if I can ungroup it. So you see, I can ungroup them. So I'm back to 2 separate ones. But for this one that is merged, if I go back to edit, you see, there is no ungrouping. I cannot ungroup it anymore because they are merged together. So these are the differences between grouping and merging. Now let's go back to the collection. So what do I have here? So in this case, I have all of these walls and I can group them together or leave them as one, as individual one. I have a sofa and a door in this room. And this Pioneer robots, I changed the script of it. So instead of doing navigation, it just goes straight. Why? Because I wanted to hit something. So if you look at the script, I made it extremely simple. Both of them the same velocity, go just straight forward. Because again, I want a collision. And for that, I need to detect the collision of this robot with any of these objects. And I want to show it to you down here. So let's see, when I run this, look at here, it says no collision detected. As soon as it hits, you see now it says collision detected between robot and scene. Which object? The sofa, and which object? The Pioneer P3DX. So it detects there was a collision and it tells you it's between which 2 objects. Do you see that? So how do I do that? The way to do it is, as I said, by script. So this script here shows you how I combine door, the sofa, and the walls into what we call a single collection, and then check whether this robot has a collision with any member of the collection. So let's go ahead and look at this code here. So what do we do? Here I get the name of the robot and I get the handle of it, right? And then look, the first thing I do, I create an empty collection. So I say, go ahead and create an empty collection and get me the handle of it called collection handle. Then what? Add item to collection. So I want to add those objects to the collection. How? I said, go to this collection handle and then sim handle all. What does sim handle all means? Means all of the object in the scene, including the robot. So every object in the scene, wall, sofa, door, robots, add them all to this collection. How do I know it is adding? Because of this 0. This 0 in the add collection means add everything, and this -1 is basically for everything in the scene instead of everything within a tree or within an object in the scene. So this is with respect to the scene, add everything. But now I want to get rid of the robots, right? The robots should get out of this collection so it can have collision with it. So now time to get the robot out of the collection. How? I use the same command. I pass to it the collection handle. Okay? And then I say, go ahead and find anything that is a tree in this simulation. Okay? And the name of that handle is this Pioneer 3X, and then 1. 1 instead of 0 means what? Means get rid of, means subtract instead of add. So subtract the robot handle tree, all of it, from the collection, right? So you see, as I said, the robot is an entire tree. So get rid of all of these members. Anything in this tree, get it out of the collection. Yes? Get rid of everything in that tree, call it, leave it as robot handle. Now your collection is everything else. Now it is time to check the collision. So what do we do? How do we check the collision? First thing is you need to make sure all of the objects are collidable. If the objects are not collidable, you cannot check the collision. So one way of doing that is to just double click on each one of these items, these objects, and make sure they are what? Collidable. And that's what I did here. Or in the code, you can check whether the objects are collidable or not. And this is exactly what I have done here. And you see it's optional. And you can do that with this command sim get object special property. So here you see I'm using a for loop, and it goes from 1 to the number of objects in the scene. How do I know objects are what? First, I need to use this command sim get collection objects of collection handle. So I go to all of them, and this is just for the objects, not the robot. And then if these objects do exist in the collection, then from 1 to the number of objects, I define the handle of that object H. I pass it to this command special property. I get P. And then if P and special property collidable, which means if P is a collidable object, then basically if it's not, or it, and kind of make it collidable. Okay, so here is forcing that property by or to make it collidable. So if it's not collidable, you are forcing it. And this part is completely what? Optional. So you don't have to do it in this case because I already did it manually. But if you want, you can add this part to your code. What is the next part? This part is to keep displaying a message until so much time is passed, then change the message. Because if I don't do that here, when I show this status on the status bar, if I don't put a delay in it, this is going to write this no collision or collision back to back very fast. So here I'm trying to slow down and make it write it either one of these no collision or collision at a slower rate. So that's why I added these times here. Now, in the sensing, what do? We need time because we need to see how much time has passed. So we update. And this is that part that if so much time has passed, then it updates. But this is the major part that checks the collision. So what is this part? First of all, it makes sure that the robot handle does exist. If the robot handle does not exist, if there is no robot here, no tree of robot here, this tries to avoid the code basically failing and breaking down. In this case, since I do have a robot, I can just go ahead and I can comment this portion out. So the major command, as I said, is this one, sim check collision. What do you pass to it? You pass to it the robot handle and the collection handle. And it gives you two things, a result and a pair. The result of 1 means there is a collision. The result of 0 means there is no collision. And the pair gives you the name of the two object handles between which the collision has happened. So it says if the result is 1, if there is a collision, update your time. And then what? Now you need to say the collision happened between what and what. So here you need to go to the pair and look at object 1 and object 2 of that pair and get their object alias or their names and call them A name and B name. These are the name of the two objects between which the collision has happened. And once you have them, you can say, hey, the colliding pair is object A and object or object B. Okay? So this is what updating the status bar, right? And if there is no collision, then go ahead and show this message that no collision was detected. Okay? The rest of this command, this set integer signal and so on, is just to reset the status of collision. So if there is a collision or no collision, this is how to reset the status of collision. So these are not super critical commands. The important one is, as I said, working with this pair and the elements in the pair. And if the result is 1, go ahead and do the job. Okay? So this is your whole code, and let me run it again for you. So right now, look, when I run, it says, hey, no collision, no collision. But as soon as it hits the sofa, look, it says now the collision has happened between what and what? Between these two objects. Now, if I move this robot and make it hit another object, so let's see if I can make this guy hit a wall or something like this. So now look again, no collision until it hits the wall. And there we go. You see, it is hitting. And now it says between Pioneer and visible. What is visible? You expect it to say an 80 centimeter high wall or something. But since I grouped these guys together in one object called walls, it basically has a visible, which is all of this merged together as one object, and it says it is hitting that one. If you didn't group them together, it would say wall number 0, it hits wall number 0, or wall number 1, or wall number 2. But when you group them together, it just uses a single object handle for all of these walls. And that's the same if I, for instance, grab this guy and bring it right here, right? So it hits this wall. Look again. You see? It hits that wall, which is a different wall, but you see, again, it says, yeah, it hits visible. Visible is also this wall. So it's the basically alias for all of these walls that are combined into or grouped into one object. You see, I can move all of these walls and place them wherever I like because I group them together. So hopefully the idea of collection, tree, grouping, merging, and so on is clear to you, and you learned how to create a collection by adding a bunch of objects, by removing objects, and by using a command like sim check collision, or you can use a similar one for proximity sensors. Okay, thank you so much for your attention. I'll see you in the next video.